All right, section 4.2 is prime and composite numbers. So grade 4 Common Core says that students should be able to find all factor pairs for a whole number from 1 to 100. They should know that a whole number is a multiple of each of its factors. Determine whether a given whole number between 1 and 100 is a multiple of a given one-digit number. And determine whether a given whole number in the range from 1 to 100 is prime or composite. So those are the things we're going to be looking at here in this section. These rectangles represent the number 18. How could you rearrange the 18 squares into rectangles? So this is helping kids to visualize the number 18 as a product of its factors. So I could write 18 as 1 times 18. That gives me a square here, or a rectangle, sorry, that's 1 by 18. Or I could write 18 as 2 times 9, or I could draw the 18 rectangles or 18 squares into a rectangle that's 2 by 9, or I could do 3 by 6. Okay. So 18 has 6 positive divisors. Their divisors are 1, 2, 3, 6, 9, and 18. Okay, so this table is counting the number of positive divisors of given numbers. So we saw that 18 had, 6 positive divisors. So 18 is going in the 6th column here because it has 6 positive divisors. Okay, we identify numbers less than or equal to 37 in this table. So 1 is the only number that's going to go in the 1 column. Its only divisor is itself, 1. Any other number is going to have at least 2 divisors, itself and 1. So these numbers here in the column 2 have 2 divisors. Its 2 divisors are exactly itself and 1. Column 3 are numbers that have 3 divisors. So let's just look at 4, for example. 4 has divisors. Well, 4 has divisors 1 and itself, and also 2. And those are the only divisors of 4. Similarly, 9 has 1, 9, and 3, and so on. The numbers in column 4 have 4 divisors, so let's look at 6, say. What are the divisors of 6? Well, always 1. Also 2 divides 6, 3 divides 6, and 6 divides 6. And those are the only divisors of 6. So 6 has exactly 4 divisors. And so on, okay? So 24 has 8 divisors, 36 has 9 divisors, etc. So I've got some questions here for you. We've already talked about number 1. The only entry in the 1 column is 1. And that's just because 1 is the only number that has just 1 as its divisor. Any number larger than 1 is going to have 1 and itself as a divisor. I want you to think about these other questions. So I'm going to let you think about these, and if you have questions, you should send me an email or visit during office hours. But you should try this out just to get a feel for counting the number of positive divisors of different numbers. All right, so a prime number is a number that has exactly 2 distinct positive divisors, itself and 1. So 1, the number 1 is not prime, but everything in this 2 column is prime. These are exactly the numbers that have 2 divisors, itself and 1. Any number that is not prime is called composite. It's going to have at least 1 other divisor or factor other than 1 in itself. So everything in columns 3 through 9 are composite numbers. The number 1 has only 1 positive factor. It's neither prime nor composite. Okay, so 1 is special. Let's try showing that the following numbers are composite. So to show that it's composite, I just need to show it has another divisor besides 1 and itself. Well, in the last unit, or in the last section, we talked about the divisibility tests, and those will be really helpful to us here. So 1,318, is that composite? Sure, it's composite since let's say 2 divides 1,318. Now, how did I know that? Well, I just looked at the last digit. 2 divides 8, right? That was a quick check. Can you find something that divides 2,781? Well, let's look at the sum of the digits. 2 plus 7, whoops, that's another 2. 2 plus 7 plus 8 plus 1 is going to be 18. And 3 divides 18. So 3 divides 2781. So that implies 2781 is composite. What about 1001? So you might pause the video and try this yourself and then come back and see what I do. I'm going to do the test for 11. So remember the test for 11, I'm going to start in the ones place and I'm going to subtract the digit in the tens place and then add 0 and then subtract 1. That gives me 0. And 11 does divide 0. So by the test for divisibility, 11 divides 1001. So 1001 is composite. What about this last number? This last number, it looks a little more complicated. I've got 3 times 5 times 7 times 11 times 13 plus 1. So what could you tell me about this product here? I'm multiplying a bunch of odd numbers. What happens when I multiply odd numbers together? Well, anytime I multiply an odd times an odd, I'm going to get another odd value. So this, I don't know what it is, but it is an odd number. Okay. So what I have is an odd number plus 1. What happens when I have an odd number plus 1? That means the total here is an even number. And what do we know about even numbers? They're divisible by 2. So 2 divides 3 times 5 times 7 times 11 times 13 plus 1. And I didn't even have to figure out what that number was. So since 2 divides that, that means that the number is composite.